Welcome everyone, I'm Mr. Eves and today we're going to be going over the Chapter 5 test review. And to start off, I'm going to be talking about the whole chapter test review. So for Chapter 5, we're going to go over it so you can be prepared for tomorrow's test. So let's start off with number 1. It says, which of the following numbers is not composite? So not composite, that's key. When it's saying not composite, let's go ahead and kind of identify what not composite means. Not composite, get my pencil all ready to go, really means prime. Okay, so we're saying which of the numbers is prime. So if it's not composite, it's prime, and so we look at these four answers. Well, 22, we know that it's not prime because it ends in an even number. The only even number that's prime is the number 2. So 2 is the only even prime. So 4 is also even, and so we know that that's not prime. 27 is odd, but let's think about the factors. Is there any numbers that go into 27? And the only numbers that go into 27 are, well, 1 goes into it, 27 goes into it, 3 goes into 27, because 3 times 9 is 27. So we automatically can rule that out, because remember, prime means that it only shares 2 factors. So that leaves us with D. We kind of ruled that out as we went across, but 3, the only factors of 3 are 1 and itself. And so that is not composite, also known as prime. Now, number 2, it says which of the following numbers is prime. So the key thing that we're looking for, just like number 1, is the prime number. So once again, we start off and we ask ourselves, is there any numbers that go into 21 besides 1 in itself? And I'll go through my divisibility rules. 2 plus 1 is 3, and 3 goes into itself. So 3 goes into 21 7 times, so I know it's not that. Well, 6 is even, so we can automatically rule that one out. 28 is even, and so that's pretty straightforward. And we could kind of go through our divisibility rules on that to kind of see which ones work out best for us. But 23 is prime. Now another thing, I'm going to be letting you use your planner on the test, and in the planner it has identifies some prime and composite numbers for you. And so you can kind of go through your divisibility rules and rule out which ones are not prime, and that'll kind of help you. Remember, not composite means prime. So number 3, the next one, it says write the prime factorization of 45. And I'm going to show you this using the ladder method. And basically what that means is we go ahead and construct a box-like ladder. So I'm going to have a box right here. I'm going to go ahead and put my number 45 in there. And this is really cool because we can kind of just go through it and really hit this and find out what the prime factorization of this number is. Now you can use factor trees on this. I personally like this way better because it's a little bit more clean and a little bit more straightforward. So we ask ourselves, what's the smallest number that goes into 45? And so the smallest number that goes into 45, well, 2 doesn't go into it because it's not even. And I'm not using 1 because 1's not going to change anything. So, and 1 isn't prime. The numbers out in front, we want them to be prime, and that's why we're asking the smallest number. So 4 plus 5 is 9, so 3 does go into it using our divisibility rules. Get 3 there. And when we're done with that, we put another box down below to make our ladder. And so 3 goes into 45 15 times. And then we start all over again. What goes into 15? What's the smallest number besides 1 that goes into 15? Once again, 3 goes into it. And 3 goes into 15. How many times? 5 times. So 3 goes into 15 5 times. And what number goes into 5 besides 1? Well, 5 goes into itself. And that gives us with 1 left over. So 5 goes into itself. Once we hit with 1 at the bottom, we're done. And so we can kind of look at it, and we take the numbers out in front. So we take the number 3, 5, and 3, or 3, 3, and 5. And so over here we'd write 3 times 3 times 5 is the prime factorization of 45. Now we can double check this to make sure it's true. 3 times 3 is 9, 9 times 5 is 45, so yeah, that works. All these numbers are prime, so 3 is prime, and 5 is prime, so that works, hence prime factorization. Let's go ahead and do number 4, exact same thing. I'm going to set it up, and actually I'm going to do number 4 using factor trees. Even though I like the ladder method, factor trees, I'm going to show you how to do this. So what you do is you make your branches, and you just choose 2 numbers that go into 56. And so I'm going to go ahead and choose 7 and 8, because 7 times 8 is 56. And once I have that, I ask myself, does 7 break down anymore? And if it doesn't, then we go ahead and it bears its fruit. So it grows a fruit, doesn't go any further. But 8 has numbers that go into it, so we continue out the branches, hence the tree. And so we go 2 times 4 gives us that. Then we ask ourselves once again, what goes into 2 doesn't go any further, so we're good there. There's our fruit. And then 4, well, it can continue to break down. And so the factors of 4 are 2 times 2. And we go ahead and put that around the 2's. And there we go. So all the numbers that we just barely circled, those are our prime factorization. So that gives us 2 times 2 times 2. Make that times a little bit better, times 7. Well, let's look at it. 2 times 2 is 4, times 2 is 8, times 7 is 56. So yeah, those are all prime. And remember, 2 is the only even prime number, and so that does equal 56. So that's the prime factorization. You'll also notice that prime factorizations are found in your planner too. Alright, this next page, well, let me go back to this other page really quick. So this is just the basic comprehension of prime and composite numbers, and it talks about prime factorization. So really simple. You have 2 methods. You have the ladder method, and I'm going to go ahead and write that. So we have the ladder method, and this is my personal favorite. Now the key in the ladder method is the numbers we choose out in front have to be the prime numbers, so I choose the smallest number that goes there. So that one's a little bit different. And then we have factor trees, which a lot of you are probably familiar with. So factor trees. Alright, the next page that we're going to be working on is 5 through 8, and basically we're going to go through here and we're going to say which is not a factor of 42. So factors are the numbers that can go into that number. So we're saying keyword not a factor. So I'm going to highlight that, not a factor. So I go right here and I say, well, 7's a factor of 42 because it can go into that. So 7, so that's not it. 7 times 6 is 42, so that's not it. Does 42 go into itself? You bet, it's a factor. Now, this one is kind of confusing, but this is a multiple, not a factor, so we could multiply 2 times 42 to get 48, and so it's not a factor. Factors are always smaller or equal to the number that we're looking at. So in this case, it's equal to 42 or smaller. Those are factors. Anything greater are multiples because we have to multiply to get higher. So there we go on that one. It says find the greatest common factors for 36 and 24. Once again, I'm going to go ahead and apply the ladder method. Now I really like the ladder method on this because it makes it really easy to work. And so I go 30, oh, let me fix that out. So 36, and I take my 24. And I ask myself, what's the smallest number that goes into 36 and 24? And we know that they're both even, so we know that 2 goes into it. So 2 goes into 36, And so then I'm going to put my next step of ladders down. And say 2 goes into 36 18 times, and 2 goes into 24 12 times. Then I ask myself, start over again. What's the smallest number besides 1 that goes into 18 and 12? Well, we see it's even again, so 2 goes into it. And so I'm going to go ahead and put my next ladder down. And 2 goes into 18 9 times, and 2 goes into 12 6 times. Put my next ladder down. And the smallest number that goes into 6 and 9, I guess I kind of got ahead of myself. Let me go back just one step. And so I say smallest number that goes into 9 and 6 is 3. And go ahead and put my next ladder down. And so 3 goes into 9 3 times, and 3 goes into 6 2 times. Now, when we get to a point where nothing goes into it besides 1, so the only factors that are shared commonly by 3 and 2 are 1, and so we're done. We stop right there. And so the numbers outside are the greatest common factors. So what we do is we take those numbers and we're going to go 2 times 2 times 3, and we're not going to leave it like this. We're actually going to multiply it out, which is equal to 2 times 2 is 4 times 3 is 12. So the greatest common factor of 36 and 24 is 12. So we got our little chart there. So I really like doing the ladder method. It makes it really simple. Also in your planners you can do the prime factorization to see and circle the ones that they have in common. Once again, I'm going to go ahead and do the ladder method on here again so you can kind of see that process. And so we start right here. And I'm going to put 21 and 18. So I say, what's the smallest number that goes into both of those? Well, 2 doesn't go into 21, so we're done there. 3 goes into 21. Does 3 go into 18? And you bet it does. And so now I go ahead and put my next ladders down, and I say 3 goes into 21 7 times, and 3 goes into 18 6 times. Now, only factors that are shared by 7 and 6 are 1, and so I'm done. So the greatest common factor of 18 and 21 is the number 3, because that's the only number there. And so that's pretty simple. So we come right here, pretty straightforward. There we go. Now, equivalent fractions, really easy. So you notice that our bottom is 7, and on all our denominators they're 35. So what times 7 gives us 35? I'm going to go ahead and write a visual representation. So we have 7, and that equals something over 35. And we're trying to figure out what that something is. Okay? So I asked myself, what times 7 gives me 35? And so I know that it's 5. And whatever we do to the bottom of the fraction, we got to do to the top. So if I times the bottom by 5, I got to times the top by 5. And so I'm going to go ahead and times that by 5. And so 5 times 4 is 20. So that missing spot is 20. So we can go ahead and find 20 35ths, which is D. Oops, wrong one. There we are. So that's that section. Okay, let's go to the next page. So now we're dealing with this. It says write the fraction in simplest form. So we come over here to number 10, and so we have 48 over 64. Now there's multiple ways to do this. You can say, what's the biggest number that you know that goes into both of them? What's the smallest number? I'm going to choose one of the biggest that I think that goes into both of them, and we'll just kind of see if that works. So I know that I can divide the top by 8 and the bottom by 8, because 8 goes into both of those, right? And so how many times does 8 go into 48? Well, I know it goes in 6 times, because 6 times 8 is 48. And let me make that 6 a little bit better. And then how many times does 8 go into 64? Well, 8. Well, now I notice that it's not all the way simplified because they're still both even. And so I probably could have went one more time. And so I'm going to divide the top by 2 because they're both even. And that gives us 3 over 4. And so the simplest form, once you get there and the only common factor that they share is 1, then you're done. Because the only thing that goes into 3 and 4 are 1. And so that's one thing that you can kind of see. Now you could have skipped this step right here if you notice that 2 times 8 is 16. You could have just divided 16 into both of those and that would have given you the 3/4. But I wanted to show you a second step. So if you went and saw that, you could do it in one step. You could have done it in like 4 steps. Divide it by 2 each time, or divide it by 4, whatever you thought that it would work out with. Now, it says which of the following fraction is equal to 3/5. Once again, we just have to find our bottom. So I'm just going to go ahead and talk you through this one. So what times 5 gives us 10? 2. So is 2 times 3 6? Oh, weird. It's that first one. Pretty simple and straightforward. This is known as the reciprocal. That's never going to be equal to it. 15, we times 5 times 3. 3 times 3 is 9, so that's not even close. And same thing, 9/10, if you just think of it as a fraction, not even close to 3/5. Okay, least common multiple on 12. We worked this in class, but I still want to talk about it a little bit. So we take the numbers 16, and 24. Now I'm going to show you what I like to do. There's different things that you can do. You could use prime factorization to find this. I just like to count by it or multiply by it. So multiples of 24, 24, 48. Okay, and we could go on and on. So I'm going to go one spot, and then I'm going to do the top for 16. Multiples of 16 are 32. And I'm going to keep on checking, so 16 is 32. And then I add 16, or 16 times 3, or 16 plus 32. That gives me 48. And as soon as you find a number that they both meet, that first number, that's known as our least common multiple because we're multiplying. Right here on this one we have 2 times 24 gives us 48, and this is 3 times 16 gives us 48. So that's our least common multiple. So 48. Oh, that was a beautifully drawn little oval, whatever, ellipse. And so that got the LCM of 16 and 24 is 48. Now, once we found the LCM, now you're going to notice about the least common multiple. Multiples are going to be greater than the largest number or equal to it. So it'll never be smaller than these numbers. It's kind of tricky because it says least, and so you're thinking, oh, least is kind of small. And it's not necessarily that, because multiples are going to be bigger than that number. They'll be equal to the larger number or bigger. Remember, factors, greatest common factors, was equal to the smaller number or smaller. So don't get that confused. So least common multiple, just think of multiplying. This number is going to get bigger, this number is going to get bigger, and so we're finding the smallest number that they both go into, that they both multiply up to, I guess we would say. So we go right here and we take 3 numbers now. We have 4, we have 6, and we have 9. Let me make 9 a little bit better. And what I like to do is I like to take the large number, because then I can see if the smaller numbers go into it. So I go right here, 9, 18. Does 6 go into 18? Yes, but does 4? No, because 4 times 4 is 16, so not quite. 27, does anything go into 27? Well, no. 9 does, times 3, 36. 6 goes into 36, and so does 4, because 4 times 9 is 36. So there it is. So our least common multiple, the LCM, let me get that a little bit bigger. LCM of 4, 6, and 9 equals 36. So that's pretty straightforward. You can kind of look at that. Pretty easy. Basically, it's like you're counting by a number and you're asking yourself, does those other numbers count up to that number? Let's go to the next page. So on this next page, we have 14, 15, 16, and yes, I know I skipped 17. I kind of numbered that wrong, but that's all right. So it says, order these fractions least to greatest. Really simple. Since they share a common denominator of 13, you just go the smallest number to the largest number. So that would be, let's go ahead and write it over here, 1 over 13. And this is least to greatest. Let me make that look actually like a 13. And then we have 6 over 13. And finally 9 over 13. And once again, this is really simple because you can kind of cover up the bottom of the 13s and just go 1, 6, and 9. Really simple and straightforward. Write the mixed number as an improper fraction. Now, we use the wording 3 and 5/7. So what we're saying is we have 3 wholes and 5/7 of a whole. So we go 3 and 5/7. So that's, in word form, that's kind of how it looks. Remember this, we go 3 times 7, and that gives us 21. And then we take the 21 and we're going to add it to the numerator and make that an addition, and that gives us 26. I'll make that 26 a little bit bigger. 26. And we're going over. Now this is really simple. We just bring that 7 right over. So 26 over 7. And we're done. And so there's your answer. Remember, you just take the denominator, multiply it by the whole number, that answer, and add it to the numerator, and then bring your denominator back over. Now, taking the improper fraction of 17 over 2, this is really simple too. You can kind of do it in your head. This is equal to, how many times does 2 go into 17? So I say 2 times 8, so 8 whole times, and 8 times 2, so I can bring that 2 over. 8 times 2 is 16. 16 minus 17 is 1. I have 1 left over. So we're done right there. So improper to mix, mix to improper, pretty easy and straightforward. Now let's do one more quick example on improper fractions. Now the nice thing about this one is, let me get to the pen tool. We have 35 over 20. And what I'm going to do is I'm going to simplify first. And so 5 goes into both of those. So 5 goes into 35 7 times, and 5 goes into 20 4 times. And when I simplify first, then I don't have to simplify anymore. So then I say, how many times does 4 go into 7? 4 goes into 7 once. And bring my denominator over. 4 times 1 is 4. Subtract from 7, and that gives us 3. So 1 3/4. And so there we're done. So you notice that I simplified my fraction first, and then I changed it. You can do it both ways. So you can go 20 goes into 35 once. That leaves you with 15 left over, and then you'd have to simplify that to get 3/4. So either way, you can do it. The next slide, this is we have 2 more sections and then we're done. You're probably getting sick of talking or hearing me talk, and I'm getting sick of talking, so we'll go through this pretty quick. I just want to make sure you understand this for tomorrow's test. Number 19, pretty simple. You just say it. And I'm going to show, I guess I can just show it right by it. Don't need to really spend a lot of room on it. And so we say 1 and, so I know I'm going to have a whole number, and 35 over, because that's 35 hundredths, 1 and 35 hundredths. And I know 35 hundredths is going to simplify down because 5 goes into both of those because of my divisibility rules. So 5 goes into 35 7 times, and 5 goes into 100 20 times. And there is my mixed number. Pretty simple and straightforward. We're just going to kind of breeze through these ones pretty quick. How do we say this one? Right here on number 20, we say 45 hundredths. And so I'm just going to go ahead and write 45 over, this equals 45 over 100. That's a nice zero. And once again, I know that 5 can go into both of those, so 5 goes into 45 9 times, and 20, 9/20ths. And so I'm looking and saying that is in simplest form because only factors that 9 and 20 share are 1. Alright, 3 and 4/10, 21. That's how you say it. So we say 3 wholes 4/10. It's really easy when you can just say those. And that's divisible by 2, so that's still 3 and then 2/5. Get that one all squared away. Now this is in words, no different, 3 and 4/100. So that makes it really simple. So we say 3 and 4 over 100. And that can simplify to 3 and, because 4 goes into 100, so 1, and if you think of quarters, there's 4 quarters equal $1, or like 100, so 1/25. So we kind of just blew through those ones because that's pretty simple. You just say it, you write the fraction, and then you can simplify. Now on this last page, we actually have to use long division to solve these, and pretty straightforward. We just take the 3/8, and remember the 8 is the number that we're going to be dividing by, so we have 8. 8 divides into 3. Now we're automatically going to say that it's 3.0 because we know that 8 doesn't go into 3. I'm going to bring my decimal up, and it goes into 3 0 times. 8 goes into 30 though. It goes, let's see, 8 times 3 is 24. And we go ahead and subtract. That gives us 6. I'm going to add a 0 and bring it down. 8 goes into 60 7 times. 7 times 8 is 56. And that gives me a 4. I'm going to add a 0. And I'm going to go ahead and bring this down. And so 8 goes into 40. 5 times actually goes evenly. So 8 times 40 is 40. And so I'm left with 0 remainder. Remember, this is known as a terminating decimal, and so that doesn't repeat forever and ever. I'm going to go ahead and do this one really quick, and then I'm going to talk about these other two. So once again, the denominator is the number you're dividing by. I'm going to go ahead and put that as 2.0. Bring that up. Start with a 0 because 11 doesn't go into 2. 11 goes into 20 once, and that gives us 11. And we subtract 19, right? Or not 19. That gives us 9. And then we add a 0 and bring it down. And bring a 0 down. 11 goes into 90 8 times. Make that a better looking 8 times. And that's 88. And that leaves me with 2 left over. Now, one thing that I noticed, and you might not notice it right off at the beginning, but I started off with 11 going into 2, and then I got another remainder of 2, so I'm saying 11 goes into 2. That means that that number is going to repeat, but I'm just going to show you. We add a 0, we add a 0, and bring it down. That gives us 20 again, and that gives me a 1 out here. And so that's 11. It's going to give me 9 again. I add a 0. And you should already be noticing, hey, wait a second, this is looking like something's going to happen. It's going to repeat. And it does, because 11 goes into 90 8 times. So we look at those, and we say 8 and the 1 and 8 are going to repeat. Instead of writing it out, we just do the line over it. and we can go ahead and get rid of these extra, and we're done. So that's pretty simple and straightforward. So that's a repeating decimal. Remember, terminating decimal means that it stops, that we have a remainder of 0. Repeating decimal is the remainder never gets solved, and so it's just going to go on forever and ever. Right here, 2 and 7/12. That's really written as 2 and 7/12. Now remember, a fraction is really division, and so we can just say 2 and 7/12, and I'm going to forget about the 2 for a second, and we can just say that that implies 7 divides 12. And I'll let you do this on the calculator. And so you go 7 divided by 12 on the calculator, it'll give you some decimal, and then that decimal, you put the 2 back in front of it. Put the 2 back in front of that answer, decimal answer, and that'll help you solve for it. Do the same thing on number 26, 1/10. And that's really simple, because 1/10 you just say 3.1, because 1/10 is a tenth. And so that's how you say it, 1/10. And so that one is pretty straightforward. We don't even need to use a calculator. 3 point, because and is decimal. I'm just going to make a little side note that and decimal mean the same thing. I hope you enjoyed this chapter test review. On number 25, you're going to have to use a calculator to solve. I'm not going to go ahead and do that. I'll let you do that. Just remember, you just take 7 divided by 12, because fractions is just another form of division. And good luck on it. Hope you have 100% tomorrow. We'll see you tomorrow, and good luck.